Hello, participants. Remember, earlier we were discussing about testing of hypothesis or significance testing. And here in this part, first I have covered the conceptualization or the concepts that are related to testing of hypothesis. After that, I have introduced the four situations uh, that represent the different type of tests, like one sample test, two sample tests, and more than two sample tests. And remember, we started with one sample t-test, where we examined a particular value that the average of the sale is equals to 75 or not. And through that, I have introduced the concept of the testing of hypothesis, as well as we perform this test on SPSS. And here I have discussed the two variants. That is the one tail test, and that the another one is the two tail test. Now we are moving forward, and now we are considering the second situation. Remember, the second situation was related to the uh, comparative analysis of rural and urban area. So here, uh, let me show you that part also. Like this is the case that we were discussing. Claim that rural outlets are giving higher sales as compared to urban outlets. Just for the demonstration purpose, I am doing this for Q3, that is the third quarter sale. You can repeat it for Q1, Q2, and Q4. So here, the objective is performing comparative analysis of two groups or two samples, and these two samples are independent of each other. So we are considering two samples independent comparison, independent test. And remember, here we are comparing that rural outlets are giving higher sale as compared to the urban outlets. So we propose the null hypothesis, which assumes no difference or the difference is nullified as average sale of the rural outlets, that is being denoted by mu r, equals to the average sale of the urban outlets. Obviously, it goes against the claim. So if this is the case, then we can say that claim is wrong or the perception is wrong that our rural outlets are giving higher sales as compared to urban outlets. And for H1, H1 is opposite to the null hypothesis, since null hypothesis represents the claim is wrong. So the opposite would be claim is right. And the claim is right means rural outlets are giving higher sales as compared to urban outlets. So this is H1, right? Now, as we have discussed earlier also, this all the units that belongs to the first group will not belong to the second group. So this type of situation is known as independent samples, right? That's why the word is independent. Moreover, since the standard deviation of the two groups are unknown, so here we will be using t-test. So the proposed test would be two independent samples t-test. So we are going to do this test on SPSS, then we are discussing the output. So let me change the screen. So this is the case, this is the data that we were discussing. So as we have discussed earlier also, all the analytical tools are available under the this analyze option. So in analyze, we have the drop down menu. And as we go to the compare mean, in the compare mean, we have already used one sample t-test. Now we are going to do independent sample t-test. So this is the dialog box of independent sample t-test. So here we can have more than one test variables also, like you can select all Q1 cell, Q2 cell, Q3 cell, Q4 cell simultaneously, and the combined output would be there. But just for the demonstration purpose, I am selecting the sales of the outlet in the third quarter. Now, the second box is related to the grouping variable. So here we will be selecting the type of outlet. Remember, the rural and urban classification is as per the type of the outlet. So we select type of the outlet and enter that in the grouping variable. Now it is asking us to define the groups. So we can define groups as 2 and 1. Now, since t-test is symmetrical, so it doesn't matter whether we are testing mu1 equals to mu2 or we are testing mu2 equals to mu1. So it doesn't matter that we enter group 1 as the rural or the group 1 as urban. In both the situation, things remains the same. So this is the thing. And now we press OK. So this is the output. This is the T sample output. Here, the first table is actually the descriptive statistics descriptive table. It tells us that the number of rural outlets are 23, number of urban outlets are 37. The average sale of the rural outlets is 64 something, 64,000, and the sales of the urban outlet is 61.32. Right? So as we have discussed earlier also, there will be some difference in the sample value. Now we are going to examine whether this difference in between 64 and 61 is significant or not. So for that, we will be discussing the independent sample t-test. Now as we look for the independent sample t-test, it actually consists of two parts. On, on the left side, as you see, here we are having a test, Levenet test of equality of variance, and on the right side, we have t-test for equality of mean. So why this is so? Because there are two tests that I will be showing you through the slides also. That one test is related to the assumption that the two groups are having equal variance, and another is related to when two groups are not having equal variance. Right? So if two groups are having equal variance, then we will be selecting p-value as 0.149. And if two groups are not having equal variance, then we will be selecting p-value as 0.115. So first we have to decide whether we should go with the equal variance, that is the first row value, or we should go with the unequal variance, that is the second row value. So here we will be first discussing the results from Levenet test of equality of variance, which examines whether the two groups are having equal variance or not. So we will be discussing Levenet test of equality variance first. Then we will be selecting the next part. So here I will be using these values. I am going back to my screen, the second screen. So here, as we have discussed earlier also, that uh, first we will be examining that we will be whether we should go with the equal variance or we should go with the unequal variance. So first we will discuss Levenet test of equality of variance. Though this is not the part of the main t-test, but in order to decide which one is to be used, we will be using this value. So as always, the null hypothesis proposes that there should not be any difference, right? The difference should be null. So H naught would be two groups or two samples have equal variance. Now, as we see for the p-value, the p-value that is given here for the Levenet test, that is significance, this is 0.052. And this value is greater than our taken or the default level of significance, that is 0.05. So we do not reject this hypothesis. Reject hypothesis of Levenet test. So we can say that two groups are having equal variance. So accordingly, when we go for the interpretation of independent sample t-test, so here we will be taking the assumption or that we have just examined, that equal variance assumed. Remember, if this p-value of the Leibniz test is less than 0.05 when we reject H naught, then instead of equal variance, we will be discussing unequal variance, right? So here we will be discussing equal variance. So as I have shown you also, in this case, the p-value or the significance for two-tail is 0.149. I will be showing you that again, right? Now, actually, we require p-value for one tail only. So accordingly, p-value or significance for one tail test is 0.149 divided by 2. So we will be getting 0.075. Okay, so this value is again greater than 0.05. So here we are not rejecting, do not reject H naught for T test. Right? So we can say that claim is wrong. There is no significance difference between urban outlet cells and rural outlet cells for quarter 3. Remember, this test is being applied on Q3 only, right? Maybe if we try for another quarter, there may be some difference. So just to confirm this, I will be again showing you the results, right? Here, I will be explaining this. Since first we will be discussing the Leibniz test for equality of variance. As you see, this value, the p-value for the Leibniz test is greater than 0.05, right? So we do not reject the null hypothesis of equality of variances for the Leibniz test, right? Since we do not reject, so we will be considering equal variance assumed. And the other value, that is the unequal variance, has no consequence here, right? So we will be interpreting this value only for the t-test. And remember, this value is 0.149. Just a moment. This value is 0.149. And since we have to consider this for one tail test, so we will be dividing this by 2. So this I have explained on the whiteboard also. So we will be having 0.075, which is greater than 0.05. So we won't be rejecting. So we say that the difference is insignificant, right? So this is for the third quarter. Okay, hopefully this is clear to all of you. Now, I will be, just for the demonstration purpose, I will be repeating this for Q1 also or for Q2 also. So again, we go for the compare mean, we go for the independent sample, and instead of Q3, now we will be taking Q2. This is for Q2. And if we press OK, so this is for the uh, quarter 2 cell. As you see, the values are 77 and 69. They are the sample values. We will be examining whether this difference is significant or not. So now here, first we go for the Leibniz test. As you see, the Leibniz test p-value is 0.596, which is greater than 0.05. Since greater than 0.05, it means two groups are having equal variance. So we would be interpreting this value only. Though here, apparently these two values are same, right? So for one tail, this would be 0.001 divided by 2. So we will be having a further lower value, that is 0.0005. So this value is less than 0.05. Since this less than 0.05, so we reject H naught. Reject H naught means yes, claim is right. The sales are not equal. And as we check here, the rural outlets are giving higher sales as compared to the urban outlet for the second quarter, right? So as we have discussed earlier also, that quarter-wise, there may be some difference there may in the results, right? So this is just for the repetition of the things that we have done earlier also. And to show you the notes part, right? This here I have explained the things, but if we go further, here we will be having, here I have explained the test, that is the independent sample t-test. Z-test, obviously we are not going to do. So this is our test, two independent sample t-tests when population standard deviations are unknown, right? So here, as we have discussed, there are two cases. Population standard deviation are unknown but equal, right? This is the case we have discussed. And the second case is population standard deviation are unknown but unequal. As you can check here, uh, for the standard error, we use pooled estimate, and here we are using um, the unequal variances case. And this is the Levenet test that I have explained, which is used to examine whether two groups are having equal variance or not. So this is a Levenet test that I have just discussed, right? So hopefully the two independent sample test situation is clear to all of you. Now we will be discussing the next test, that is the paired sample test. So first, I will be discussing the concept. Then I will be going back to the notes again. And for this case, we will be discussing this situation. This is the third situation. Examine the effectiveness of the advertisement campaign. Remember, as per the case, advertisement campaign was launched in the end of the first quarter, right? Or in the beginning of the first quarter. And if we expect the immediate results, so it is expected that quarter two sales are higher as compared to quarter one sales. So here we will be comparing these two tests. And since this comparison is unit-wise comparison, pair-wise comparison, so that's why this is known as pair t-test or two dependent sample t-tests with the same hypothesis, right? So here I will be showing you that part again of the case. So this is the case that we discussed, that an advertisement campaign was launched to augment the sales in the beginning of the second quarter. So first, we will be doing this, and just for the repetition purpose, we will be doing for the another uh, fact that is to be examined, that a sales promotion program was also launched in the beginning of the fourth quarter, right? So in the first case, we will be comparing the sales of the first and the second quarter, and in the second case, for the sales promotion program, we will be comparing the results, the sales of the third quarter and the fourth quarter, assuming the impact is immediate. And why we consider this independent, sorry, not independent sample test, why dependent sample test? Because when we are comparing this Q1 and Q2 sale, so for real meaning purpose, we should compare this 67 and the 77, means the pre-value and the post-value of the same outlet. Means we should not compare this 67 with 60, right? Why we shouldn't compare? Because it might be possible that this first outlet will be on the roadhead and the second outlet would be in the interior of the society, right? Or interior of some rural area. So there may be some differences among these values because of other reasons. So in order to make that differences negligible or constant, we will be comparing the pairwise comparison. That's why we will be comparing 77 with 62, or we are comparing 66 with 53. We are comparing this 75 and 63, or these values 85 and 75, means we will be comparing the quarter-wise values for a particular outlets only. Right. So here I will be using, I will be explaining the concepts more. Okay. Now, this is the next situation that, this is the third situation that we are going to discuss. This is for effectiveness of advertisement campaign. Okay, right? And for here, we will become, this advertisement campaign is being launched at the beginning of second quarter. So we will be comparing the sales of Q1 and Q2. So what would be the hypothesis since H naught assumes no difference or the difference is to be nullified? So we will be comparing the average sale of the second quarter with the average sale of the first quarter with the hypothesis that there is no significance difference. Since there is no significant difference, it means that advertisement campaign is not a success provided all other things remains the same. Means it may be possible that advertisement campaign is a success, but because of some other factors, there won't be that the increase has been balanced. Anyway, so what would be the H1? That advertisement campaign is a success. So since advertisement campaign is a success, so there should be a significant increase in the sales. Then only we say that advertisement campaign is a success. So H1 would be average sale of the second quarter is greater than average sale of the first quarter. Now here, since samples are related, samples are dependent, and the standard deviation is unknown, so we will be using two related or dependent sample t-tests, which is properly known as paired t-test. Okay, so how it works? Suppose we have data xi and yi, right? So xi is one sample and yi is another sample. This is also known as pre-post test. Pre means before the advertisement and post is after the advertisement. So we are having these values. So here the comparison would be this and this, comparison would be this and this, comparison would be this and this, right? So we will be having one more random variable that is di, which is the difference of these two values. And this pair t-test is being applied not on xi and yi, it is being applied on di. So accordingly, the test statistic would be d bar, which is the average value of d values divided by the standard deviation of d values and root n. So it will follow a t distribution with n minus 1 degrees of freedom. So actually what this test does, it converts the two sample test, the two sample t test into one sample t test. So you can say that this pair t test is actually a one sample t test. It actually behaves like a one sample t test. Okay, so that's why this is the hypothesis that we use. So it is there, that is that paired sample t-test testing difference between mean with the dependent sample, right? So here this is the hypothesis, right? And these are the values. Di's are the difference, d bar are the mean of the d values, and uh, SD is the standard deviation of these d values. And here, further, this is the SS window, which tells you about how to reach to the two independent sample t-test and to the pair t-test. So all the instructions are there, right? So don't worry about that. Okay. So this is the paired sample t-test that we are going to discuss. Now we will be running this on SPSS and interpreting the output. Right? So we go to analyze, and in the drop-down mean, we go to the compare mean, and in the compare mean further extension, we have paired sample t-test. So this is the paired sample t-test. So here we have, again, this is a t-test, so it doesn't matter. This is symmetric, so it doesn't matter that the first group or the first sample should be of Q1 or Q2. So both the things remains the same. So you can enter a number of pairs simultaneously also, but here just for the demonstration purpose, I am selecting one by one. So we press OK. Now this is the output, right? As you see here, the average sale of the second quarter is 72.431 for the sample values, and average sale of the first quarter for the sample values is 72.02. So there is a difference, right? But as you observe, the difference is not much. So we will be, anyway, also we will be examining whether this difference is substantial or significant or not. So for that, we will be using paired t-test. So as you see, this is the paired t-test p-value. The p-value is 0.688. And this is for the two-tailed test. And for the one-tailed test, we would be having the half of this value since our test is one-tailed test. So we divide 0.688 by 2. So we will be having 0.344, right? And this value is greater than 0.5, our default level of significance. So we do not reject the null hypothesis. We accept the hypothesis. So we do not reject the null hypothesis. Okay. We do not reject the null hypothesis means the difference is insignificant. Difference insignificant means apparently advertisement campaign is not a success provided all other environmental factors remains the same. So this is the first interpretation, right? Hopefully this is clear to all of you. Now I am putting this on our slides also. So I am changing my screen and right. So here, this is for the test that we have discussed. Here the p-value or the significance of two-tail, because it is being provided by the software, that is 0.68, right? But we actually require p-value or significance for one tail. Why one tail? Because it is a directional hypothesis. So this value would be 0.688 divided by 2. So we will be having 0.344, which is greater than 0.05. So we do not reject the null hypothesis. Means there is no significance difference between Q2 and Q1 cell. No significance difference between Q2 and Q1 cell. No significance difference between Q2 and Q1 cell, right? So we can say that advertisement campaign is not a success, it provided all other things remains the same. So not a success, is a failure here. Now, just for the demonstration purpose, I am repeating this um, for the sales promotion program, which is being launched in the beginning of the fourth quarter, right? So This is just the extension of this. This is just for the demonstration. We will be doing third B. So earlier can be written as third A. In the third B, we will be examining effectiveness of sales promotion program. Okay. So here we will be comparing the average sale of the fourth quarter with the average sale of the third quarter, right? So it means no significant difference because the null hypothesis is proposed in that manner. So we can say that sales promotion is not a success or a failure. And for H1, it would be average sale of the fourth quarter is greater than average sale of the third quarter. It means there is a significant increase, means sales promotion program is a success with the caveat all other things remains the same, right? So again, we will be using the pair t-test. I am running this test using SPSS. So we go to analyze. We go to analyze. Then we go the same path, compare mean. Then in the compare mean, we have a pair t-test and we will be selecting these values, that is the fourth quarter sales and the third quarter sales. So now the paired comparison is in between fourth quarter and the third quarter sales, right? So now as you see here, the values are for the fourth quarter, the average value is 74.25 thousand, and for the third quarter, average value is 62. So there appears to be a difference. We will be examining whether this difference is significant or not. So as you see here, the p-value for the two-tail test is 0.001. If we divide it by 2, it will be further lower down. So obviously that value would be less than 0.05. So we will be rejecting H naught. Rejecting H naught means there is a significant or substantial increase in the sale. And that is because of sales promotion program, provided all other things remains the same. So this is the caveat that is always required. Right? So now I will be using these values. Right? So here, as you see here, the p-value or the significance for two-tail test is 0.000, right? And accordingly, p-value or the significance for one-tail test, as the case here is 0.002 divided by 2. So this would be indeed less than 0.05. So we would be rejecting H naught. Means we can say that there is a substantial or significant increase in the sales. Right? So we can say that sales promotion program, which is being launched at the beginning of the fourth quarter, is a success with the caveat. This caveat is always required because there may be some change in the environmental condition. Success provided all other environmental conditions remains the same. Okay, so this is about paired t-test. So here we have performed all the tests that is related to the t-test. The first one is the one sample t-test, where we examine only one group or the one sample with a particular value. We will be confirming whether that value is acceptable or uh, as per the statistical concept or not. After that, we perform the comparative analysis of the two samples. The first was the independent sample, and the other one is the dependent or the pair t-test. So, whenever you have to apply the test, you have to check, you have to conclude, you have to decide whether you should use independent sample t-test or you should use dependent sample t-test or the pair t-test. Then only we can move forward, right? So these are the two tests. Remember the last case that we discussed where we require more than two samples, so that comes under analysis of variance. We will be discussing later on. Okay. So